Hey everyone, welcome to Live App Review. I'm Matt Lockyer with Near Protocol, and today we're going to be looking at cross-contract calls. So a lot of the examples that you may have seen from Near Protocol involve only one smart contract. So for every Near account, there's always, there's the option to deploy a contract for an account. But if you want to compose your apps out of many different contracts, you're going to have to deploy multiple contracts. So today, it's mostly going to be like a setup kind of walkthrough and walking through some of the tools that you've seen me use in the previous examples, and then get you acquainted so that you know what's going on when you try to set up projects that are larger than just one contract, and that you don't rely on my tools all the time, but you actually understand how to string them all together. So I think it's probably best if we just take some time to look at this GitHub repo and get ourselves acquainted. But before we do that, I'm going to show you what our contract is actually doing. So I'm going to show you that today the end result, just so you know what we're building towards, is just going to be one of these front end tests using Jest. I call them front end tests because they're like the same JavaScript that you're going to use in your front end app. But we don't have a front end app today. All we have is the test, and basically it's going to check the cross-contract calls in two ways. It's going to check whether a balance was enough of a balance. So from contract A is going to check contract B, and then contract B is going to return a balance of a particular account ID. And then contract A in a callback, so in a second cross-contract call, so it's going to go contract A, contract B, contract A. Contract B is going to call again to contract A and ask, is the balance enough in the callback? So in contract A, there's going to be a callback that says, is the balance enough? So the test is going to result in whether or not this person has enough of a balance. But it's important to note that we are always entering through contract A. So we're always entering through like this first contract, and then we're calling to contract B to check the balances. So think about it this way. Contract A could be, for example, like some DeFi app that wants to spend tokens, and contract B is the actual token contract. So contract A is going to ask contract B, does the user have enough tokens to use my DeFi app? Like, let's say we have a minimum staking requirement of 5,000 tokens or something. So contract A is going to ask contract B, what's the balance of this user? And contract B is going to come back and give the balance, but by calling a callback function of contract A. So the callback is in contract A. And then contract A can check, oh, is it greater than 5,000 or less than 5,000? Okay, well, I'm going to say you can stake or you can't stake. So that's basically it. It's very, very, very simple. Most of it, we're going to walk through the actual utilities and like how the sort of the repo set up. So let me just run this test, make sure everything's running okay. So what we're doing is we're running yarn test deploy. So what that's going to do is it's going to create two new developer accounts. So typically you only have one under NearDev, but here I have it scripted so that it creates NearDev and NearDev B. So NearDev B is going to be responsible for deploying contract B. So there's actually two Near developer accounts being created when I run test deploy and deploy the contracts. and then the contracts are being deployed to the respective account. So contract A will be deployed to this near dev account, and you can open up these folders if you want and like check the account ID. But this is all done for you, and I'm going to explain how this was all done for you, from the previous 3 live app reviews. So near dev, the folder is for contract A, and near dev B is the credentials for contract B. It's not the credentials. The credentials are in your local kind of system, but still. Anyway, those are the account names. So then you'll notice, the test pass, and we'll look into the contracts in just a moment, but you'll see I have, instead of having a folder that's just called contracts, I have contract A and contract B. So I've just laid out my folders like this. So these are full Rust projects, each with a single smart contract in them, but they're different. They just look identical. One thing to note is that these folders, like with the contracts in them, they come with build scripts. And they also come with this cargo.toml. You're gonna wanna make sure that all of these names, if you do edit any of these names, that all of the names add up. So basically, it's kind of crappy that I put contract-A because it gets converted to a lowercase anyways. So it ends up here, contract_A.wasm. Don't ask me why. It's some crazy Rust land kind of stuff. I probably should just call it contract_A so there's no confusion. So I'm going to go ahead and do that now. I'm going to clean up some of these names to make it like super straightforward. So basically we have these cargo.tomls. We've named our output to be contract_A, contract_B. So these build scripts are going to have to do the exact same thing. So we're going to have to take contract_A, and then for whatever weird reason, don't ask me why, it's just me, I turned it into contract-A, so I'm going to turn that into contract_A just to be consistent, and contract_B. Now if I change it here, that's what outputs as the WASM, so that gets copied into this output folder. And what does that get picked up by? Probably my package.json script. So I got to look in my package.json script, and I have to go and I have to edit that, right? And make sure those all add up. So everything needs to add up. So one of the things that you'll notice about dev deploy is that it goes, so it builds a contract and then it removes these near dev folders. Now, why do we need to remove them? Because otherwise we won't get new credentials. So why do we need new credentials? Because let's say we deployed our contract to one of these dev accounts and then we made an error in our contract and we wanted to change the contract. Well, then we're deploying the contract on top of the old contract. So what happens is sometimes that can mess up the storage. So the storage for the account is the same, but the contract logic is changed or the structure of the data that's being stored is changed. So that can lead to a lot of weird problems. So what I like to do is basically I like to just wipe out the accounts completely, get brand new accounts, and then deploy the contracts. So after we have removed the two dev account folders here, this is us kind of going through the steps of dev deploy. So after we've removed the dev accounts, we will call near dev deploy, and then we're going to actually tell it to deploy contract B first. So contract B gets deployed before contract A. Then what we do is we move those credentials from near dev to near dev B. Near dev is the default. And then we're going to call near dev deploy again, and we can only do this because there is no near dev folder anymore. We got rid of it. We called it near dev-B now. And we're going to deploy contract A. So now we've deployed 2 contracts. And then we call this yarn patch config. To be honest, that's just a node file that I wrote just to make my life easier. So basically what it does is it goes into your near dev folders and it finds the contract name and then it rewrites it over the config that is found in the source folder. So you'll see the source folder here has these 2 contract names. So it has contract name and contract B name. So again, contract A is probably the first one, contract name, and contract B is the other one. So what I've done in patch config is basically just read out the dev account that is in each of these folders. So you'll see there's these files that basically have the dev credentials. And I've read out that account ID, and then I've just rewritten it in the config file. So using like a regular expression. So nothing too fancy. I'm just patching the config file. So after I've deployed brand new accounts, my tests and my app and my server, they have no idea what the new accounts are unless they read it out of a config file. So obviously I had to just go and like rewrite that. So basically, that's it. That's the magic. That's all the mystery of everything. So I hope if you didn't get it the first time, rewatch that part. Sorry, but that's just me running through something that I set up to make my life easier. So I know it sounds kind of confusing, but I mean, it allows me to just kind of do like a one click, and basically contracts are built. That was contract A, that was contract B. The releases are made. The dev accounts are deleted. New dev accounts are created. Deployments are started. That's what's happening right now. Coming, going. And then that's all done. And then basically the jest test runs. So what we're looking at the end of the day is just this app test. So once it's all done, we get basically contract name and contract B name from test utils. But where does that come from? Well, it comes from the config. So it comes from that config file that I showed you. So no big mysteries. It's all there. You just have to kind of follow the path. All the way from the contract folder, the build script, where do the contracts get spit out, how are those dev accounts being created with those folders. There's a little bit of magic there with near CLI, but it's not too confusing. All right, so now that we've got that test, let's take a look at what the actual contracts do, and then how they call each other, and then I think we're done. So it's really short one today, just a quick overview of these cross-contract calls. So I mentioned that contract A is the entry point for everything, and we really only have one method we're calling. If you look at the tests, we're just calling one method of that contract, and the contracts are super simple, and they're intended to be so, just to demonstrate this promise, the promises and the callbacks. So check balance contract B is what we're going to call. Not a very pretty method name, but it's pretty explicit in what it says. So we're going to check some user's balance in contract B. So if we go to contract A, what are we doing in this method? So I'm just going to get rid of this for now. I will just hide it. So if we call check balance contract B, this is a change method, of course, and we pass it contract A's account ID. Now, the reason why I do this and I don't hard code it is because remember what I said about testing. So I destroy and rebuild the test accounts if I change my contracts, if I want to redeploy. And I don't want to have to waste time like, hand bombing in, cons of like contract IDs or whatever. If you were going to deploy on mainnet and you wanted to, maybe things were a little bit more solid, like you knew which contracts you were going to be calling, and you could just write them in here like this. So you could just say like, const, token count equals, my, there's something on mainnet called, my token.near, and you just have to make it a string. So you could do that if you were deploying on mainnet. But for now, what we're doing is everything is dynamic. We're just passing it in through the arguments to these parameters here. So contract A, and you'll see why we need that in a second. We obviously, why we need contract B because it says so in the method name. We're going to check the balance in contract B. And then we pass in the account ID of the person that we're trying to check. So then what we do is we call a promise. So we make a new promise. The promise is for the contract, it's for the account contract B that's also typically referred to as like the receiver of the function call. So basically, that's the account ID that we want to call with this promise. So we make a new promise. And then we call the function call method. So when we call the function call method, we need to tell it which method of the contract we want to call. And it's pretty low level, so it expects like a vector of bytes. So basically, you have to take like a byte string and basically call 2vec on it. The next argument is going to be the arguments. It's actually, by the way, it's a lot like these contract calls here, just without the contract, without the method name. Well, I mean, the method name comes here, and then the arguments, and then the gas, and then optionally a deposit. So it's a lot like those. So, oh no, it's reversed. It's the deposit, then the gas, whatever. Okay, just, remember that. But basically, it's the method name, JSON, the deposit, and then the gas. So here we are calling the check balance method. Let's just take a quick look at contract B so you can see that there is a check balance method. And then we are going to JSON some args using the handy JSON macro here. So basically we just can type in JSON. So we need to pass to contract B, to the method, we need to pass contract A's account ID. And the reason we need to do that is because we're going to call this callback. So we're going to call back to contract A from contract B. So we need to tell it like who we are. Hey, who's calling? That kind of stuff. Then we're going to pass in the account ID. And then you need to do a bunch of this weird conversion just to get it to a vector. And then I mentioned before, there's no deposit and there's gas. I'll talk about gas in a second, but this is 20 teragas, and that's kind of important. I'll talk about it in a sec. So after we've done this, just be aware that we do have a callback method called check balance callback. And so I'm going to go to contract B. So now we're in check balance, and we receive contract A and the account ID that we want to inquire about. Now, here's where, I cut corners to give you these quick high-level app examples. I don't have a token contract. So this isn't a token contract. It definitely is not. There's no storage. There's no nothing. So basically what I'm doing is I'm literally just checking for the hard-coded account ID Matt. And if the account ID that's passed in as an argument is in fact Matt, then I will basically spit back a balance of 1,000. So, okay, now what you probably want to do is something like in a typical kind of fungible token thing, you would have some storage here. So you'd have like, like tokens, blah, 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 unordered map, yada, 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 all that good stuff. But we don't. And then when you're in your method, you typically go like, self.get, and then you do this one to look up, unwrap something, 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 and then you would look for your balances, right? In an unordered map or something like that. One of the data structure collections. So you'd normally do that, but here I'm just looking for the hard-coded name. So I just want to be clear about that. This is like a total BS kind of staged contract. Now, what's cool is that we actually return a promise from this function. So it's a promise. It's one function call to contract A here, check balance in contract B, that calls the check balance method of contract B and returns a promise back. So basically this promise gets returned to here to this promise, but the result actually comes from, so what's wrapped in this promise is the result of another function call to contract A, and that function call first is method name, so check balance callback to vec, then JSON the amount. So what is the amount? Well, it's the amount we got from the logic in this contract. So we're actually taking the data from contract B. We could take stuff from storage. it doesn't matter. There's no weird like storage, memory, blah, 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 like stuff. You could take stuff from storage in contract B, but I'm just taking like these hard coded values and you can pass it back. So that's kind of cool. You pass it back as an argument. And again, we just had to do this type conversion stuff here. So then you come back to contract A and you land in check balance callback and you land with the amount. And then what I told you before, I had this kind of contrived example. So, imagine that contract A is some DeFi protocol and contract B is basically just the token contract. So we're calling contract B to check if the user has enough to participate in contract A. And so when we come back with the amount, we land in this callback function, and that callback function is going to determine whether or not we can participate in this protocol. So if the amount that is returned is greater than 500, we're going to return true, and if not, we're going to return false. So it's pretty hacky, pretty bad contract, totally get it. But this is not live contract review, that's Eugene. So this is live app review. So I'm just showing you the contracts so that we can get our heads around how we actually might talk to them with JavaScript and how we might set up our project to basically do this fluidly. So again, I'm not gonna really, not gonna be able to go out with a big bang on this one, but essentially that's it. So I can show you a few things, like we could change this amount. So we could say that Matt only returns 100 and then both of our tests will fail. But that's not that interesting. But it's a short one and it shows you how promises work and how cross-contract calls work. So I think they're pretty cool. What's actually going to be really interesting is when projects start putting out these fungible token contracts and other contracts in the Near ecosystem, and you can actually compose with them quite easily. As you saw here, all you really need to do is basically call into one of these contracts, and then you can pass the account ID and the method that you want to call back. So I mentioned before that one of those was going to fail because I changed the amount. I changed the hard-coded amount here. So I'm going to put that back. And actually, just for fun, let's just see what happens when we want to pass our method name to contract B. We're going to pass method name in our JSON, and we're going to go get method name in our contract here. So just to prove that you can compose and you can actually pass like a callback name. So any standards that are on, I'm going to have to check. Oh yeah, that is definitely not a string. I think inside this JSON thing, I think I should just be able to put that as is. We'll see. It's probably going to complain. Rust complains about everything. And then what we're going to do is we're going to do method name into bytes. So what should be possible in the Near ecosystem is that you can just call arbitrary contracts, or you can have a method of your contract that will allow other contracts to call it and then specify their callback by specifying their contract ID and the method that they want to call back. And then you just have to set up the standard of how you're going to call them with the arguments. So you're going to call them with which arguments and which deposit and how much gas attached. Okay. Actually, let's go over the gas thing in a second here. Well, we're going to let that deploy, and then I'll just quickly talk about gas. So you'll notice that I have 20 tera gas on the contract A call when I sort of attach the gas to the promise here. And then you'll see I have only 10 tera gas on this call. Now that's because contract A, remember, contract A is a promise that calls another method that calls back to contract A. So contract A, the original one, oh great, it passed. So that's good. So that means that our method call update worked. So little sidetrack there, but basically we passed in the method name for the callback, and then we grabbed it here as a parameter, and then we just took the method name into bytes and we made the call back. So you can make these like open protocol, composable protocol things where other contracts can basically pass in their contract ID and the name of the callback method that they want you to call. So you can make contracts that other protocols can depend on, which is really cool. So awesome stuff, cross-contract calls, really cool. But just back on this gas thing one more second. So it's really important that contract A has enough gas to pay for this cross-contract call as well. And then this amount of gas needs to be able to pay for this computation. So if you go all the way back, you basically need enough gas to pay for this, specified in this promise call here, which is attached by this amount of gas, which should also, if we're going backwards, the amount of gas that covers this and this computation checking here and all of this argument deserialization, blah, 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 should be able to be covered by this amount of gas because it is attached here, which, if we go all the way back to our app.test.js, should be able to be covered by the amount of gas that you attach when you originally call this. So if we look at app.test.js, it calls it here twice with this gas amount. But if you want to know where the gas is, you got to go to the config. So that's 40 teragas. So why did I attach 40? Well, just kind of like wanted to make sure that I was okay. I knew I was going to attach 20 here, which could be spent, and 10 here. So I just wanted to attach 40 to cover, anything else around that 20 that I had to spend. So the 20 covers the 10, and that's all good. So again, the total gas that's spent is actually much less. So if you look actually in the console, I've got this dev account, and then I've got the contract B name, which is another dev account. So what's cool about this is I've deployed these tests against testnet, so I can actually go to the Explorer and I can look at these accounts and I can check that they've actually been successful. So you can see these well, that batch transaction was the creation of the account, or it's just creating these dev accounts or test accounts or whatever. But if you look at these calls, so this is check bounce contract B, check bounce contract B. So those are successful tests. So you can see that it only used 18 teragas. So I could get away with paying much less gas in the config. Let's go ahead and change that. It's up to you. 20. So that's 20 teragas. It's just a 20 with 12 zeros after it. So kind of weird. Oh, and I didn't have to test deploy here. So unfortunately, that's going to wipe out this dev account. But once I've deployed, and if I'm just making edits to tests here, all I have to do is run yarn test. So if I'm just editing my tests, then I just have to run yarn test and everything works without redeploying the contract. So it's actually much faster. Oh, something happened here. Exceeded the prepaid gas. Okay, so there is a little bit of gas that's being spent that I'm not sort of privy to. I don't know why. Oh, again, I did it again. Yarn test deploy. Okay, well, whatever. We're just gonna go through the whole thing once more. But yeah, hopefully with 30 teragas, we don't exceed that. So what could be happening actually is that there's gas used, and then there's some gas burnt outside of this, and I'm not exactly sure why, or we need to attach a little bit more, but it didn't actually get spent. So 30 did it. So just because it didn't get burned doesn't mean that we didn't need it attached for some reason. So I'm a little shaky on those details, but hopefully I can clear that up in a future video. So if we go to this other new dev account, we see that these tests have ran. So we called check balance in contract B. And then I just want to show you, you don't have to, if you want to run the test again, and all you've done is change the config or the JavaScript or whatever, you don't have to actually, actually that's not fun. Let's actually just change the config to like 35 so you guys can see that I actually attach more gas. So remember, in this call, we attached 30 gas, we spent 18. And now what we're going to see is we're going to see 2 new method calls when these tests run, but I did not deploy the contracts again. So the contract is still the same. So you'll see 3 transactions, 6 transactions, 4, 8. Okay, so some more transactions there. And you'll see 35 gas attached and 18 gas used. And we see there's some success receipts and a bunch of stuff. This is basically success receipts are all the receipts for the individual actions. So remember, the promises are doing these cross-contract calls. So there's one promise calling contract B, and another promise calling contract A, and then there's a final receipt, I believe, that returns the result. So that's it. That's cross-contract calls. It's pretty simple. It's not that crazy, but you do have to structure your project and have everything kind of automated like I did. Otherwise, you're going to be constantly like moving things around by hand. So just make sure to like double check. If you automate things, like double check everything all adds up, the same name, stick with a consistent naming convention. Don't get too crazy. Like you don't have to start calling it, like my funky token symbol, blah, 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 like right off the bat. Just call it contract A and contract B. Keep everything simple and like super basic. Experiment with this repo, test it, break it, do whatever you want. Just some quick shout outs. Go to near.org if you want to get involved. Developers, technology, community. My suggestion is to jump into the community, jump into our Discord, jump into our Telegram. I'm pretty active in Discord and always kind of hanging around the developer channels. You can follow us on Twitter, WeChat, and also check out our awesome docs and other examples. We will be at ETH Denver. I'm already on community here. I just want to show you, you can contribute to bounties and do some coding and maybe get paid to learn a little bit about Near. You can lead a guild, so you can help us run various communities for developers in the Near ecosystem. And we're going to be at ETH Denver and just get connected to everything. There's this contributor program, and then there's a guild program, and there's the Open Web Collective. If you have an app and you're ready to go mainnet, then you can also jump into the Open Web Collective. They will help you get all the way there. All right, thank you for joining me. And I hope you learned a lot about cross-contract calls.